Okay, we are going to, this is exam 4, essay 1. We are going to talk about the kidneys. Specifically, we're going to talk about filtration, reabsorption, and we'll probably get to that point, and then we'll see where we're at from there. But filtration, we're going to start with some pressures, or first the renal corpuscle. The renal corpuscle would be this part here. Corpuscle. And this includes the glomerulus, which is your capillary bundle here, glomerulus, and your Bowman's capsule. So those two things make up the renal corpuscle. And in this area is where filtration happens. Filtration happens through the membranes there. And so first, let's talk about the different parts of the membrane. First, we're going to have the glomerulus is going to have fenestrated endothelium. So let's say this red part here is going to be our fenestrated endothelium. And the fenestrated endothelium has pores, and they're called fenestra, and they're pretty wide, and they're negatively charged, and so they repel negatively charged proteins. And so they fit smaller things through them, as well as they're charged, so they repel negative things. The next part will be our basement membrane. Our basement membrane is part of the endothelium as well, and it serves as a porous matrix for negatively charged proteins. So this one specifically for charged particles. So it's going to repel negative things, and that is because negative proteins kind of circulate around it. So it's going to repel negative things. And so the only things that can pass through this part are small, negatively charged things. So ions would be a good example. Our next part of the membrane that filters or filtrates will be called our podocytes. These are going to be our podocytes. Podocytes is the outside or the visceral layer of the Bowman's capsule, and it kind of encircles the capillary of the glomerulus, as you can see there. If we can get laser here. That is way too big. That's okay. That part right there. Kind of circles the membrane, or circles the capillary of the glomerulus. And it also has gaps in it, and we call those filtration slits. And the filtration slits are bridged by proteins, which we didn't draw, but they're bridged by proteins right here. And those proteins, there's a bunch of them, but most of them are nephrin. Could be neph1, or I think podocin is another one. But anyways, these make up a thin diaphragm here, and they are size and charge selective as well. And then the last part of the membrane that we're going to talk about are these things here. These are our mesangial cells. Mesangial, not sure how to say that, but mesangial cells are very similar to smooth muscle. So they contract, which can change the surface area of the glomerulus capillaries, and that will influence filtration so increased contraction, increased pressure, increased filtration. Also, they have phagocytic activity, have phagocytic tendencies, I would say, and they can secrete hormones like paracrine, which also will affect filtration. But the biggest thing is they're similar to smooth muscle. They can contract and change the surface area, influencing filtration. So that's the first part of filtration. Next is going to be our pressures. Our pressures, we got lots of different pressures we're going to talk about here. There's going to be pressure we have a hydrostatic pressure similar to capillaries, like we've talked about in other units. We have a hydrostatic pressure in the glomerulus, And that's going to be around 55. And hydrostatic pressure is going to be going out. So that pressure is going that way. We're going to have a B-cup pressure or a cup pressure, and that's going to be going in. And that one's going to be roughly 30, 28, around there. And these are in millimeters of mercury, I believe. And we're also going to have a hydrostatic pressure of the capillary. Nope. There's another hydrostatic pressure here. That one's roughly 15. And then we're also going to have a pressure on the outside here. An FP, we're about 10. I want to make sure I'm teaching this right. So, check these pressures. So one of them, the inside, right below Bowman's capsule, is going to be a really important one. They're all important. But it's going to end with more pressure going into the nephron than it's going back out of the nephron. And that's going to cause it to move things down into the nephron. So that filtrate will continue moving down the nephron because of these pressures. So we have hydrostatic pressure. Oh, this is the capsule. That's what it is. Hydrostatic pressure of the capsule, and then our net filtration pressure. So add all those up and the way that they're going. Let's go the other way. And we're going to have about a net filtration pressure of 10. So we're going to have about 10 going into the capsule. So that net pressure will drive things into the capsule. So that's our pressures, and that's kind of how the pressures will work. Yeah, that's filtration. High pressure is necessary for filtration, and the mesangial cells can help maintain that pressure by contracting. And then there's two types of regulation that we can talk about here. I wasn't going to talk about this in this part, but it will work well. So if we go... So the two types of regulation are our myogenic response. So this is how it kind of auto-regulates itself. There's a myogenic response. And big word, tubular, glomerular feedback. I'm going to talk through that one for sure. But smooth muscle on arterial cells contains stretch-activated calcium channels. So on our afferent arterial, this is our afferent, contains stretch-activated calcium channels. And when those are activated, so let's say when blood pressure is up, that's going to stretch the afferent arterial, which is going to activate these calcium channels, causing it to contract. So calcium channels activated causes vasoconstriction in the afferent arterial, and that is going to regulate pressure in the glomerulus. So that's one way we regulate pressure. Another way is our tubular glomerular feedback. Okay, and basically what this one is, our GFR is synonymous, not synonymous, that's the wrong word, but it goes up when our blood pressure goes up, goes down when blood pressure goes down. And so if our GFR is down, meaning our blood pressure is low, we have macula densa cells, which we're going to get to later. Macula densa cells are down in the collecting duct at the end of the distal tubule. Our macula densa cells are going to see that our GFR is down. So I guess you can look right here. So our macula densa cells are going to be about right here. And so if our blood pressure is down, they're going to notice that. They're going to get signals from that. And they're going to release nitric oxide. And nitric oxide dilates. So it's going to vasodilate the afferent arteriole. And when it does that, that brings the GFR back up, which is a negative feedback response. And then similarly, as the myogenic response, if our GFR is up, meaning our blood pressure is high, macula densa cells are going to release adenosine. And adenosine is a vasoconstrictor. So we're going to vasoconstrict, causing our GFR to go back down, which is glomerulus filtration resistance, I think. That is also a negative feedback response. So that is tubular glomerular feedback. And GFR is, like we talked about, is glomerular filtration resistance. So is it more resistant to filtration, less pressure, less resistant, more resistant to filtration? That didn't sound right, but that is it. Okay, we're going to go on to our next video. Make sure we keep these short enough. And yeah, talk about clearance.